Module 2, Lesson 2, Overview of a Virtual Machine. By the end of this lesson, you'll be able to meet the following objectives. Explain how a virtual machine is a set of specific configuration files. Describe how a virtual machine is a guest and consumer of host resources. Explain how vSphere interacts with CPUs, memory, networks, and storage. Navigate vSphere clients and be able to use the vSphere web client to access and manage your vCenter server along with your ESXi host. A virtual machine is an abstraction of software of a physical machine that turns its components into files that act like physical components. So as you see in this slide, we have our physical CPU, our memory, our disk, and our network. And what that does, it takes it, puts it all on the ESXi host, runs through the vSphere kernel, which is here, and then they're shared to the VMs, VM1, VM2, and VM3, as you see above, so it shares all of the resources. So what about your physical and virtual architecture? Virtualization is a technology that is an abstract of your physical components and puts it in software components or files that provides solutions that IT staff are faced with today. So let's take a little bit more in-depth look at physical architecture. With a physical architecture, you have your CPU, you have your memory, you have your NIC, and you have your hard drive. With your physical machine here, as you see, the CPU, memory, the network adapter, and the hard drive are all shared on this one device, 64-bit architecture, the operating system, which could be Microsoft, Apple, Linux, whatever you choose, and you got your applications. Everything you see in this block here of the physical architecture is only utilized by this machine. Now if we look at the physical architecture, we have our same CPUs, we have our memory, we have our NIC, and we have our hard drive, or SSD, or solid state. So with the virtual architecture, what it does, this CPU is used across VM1, VM2, and VM3, as you see here. Right? So with that being said, our memory, same thing. We have a pool of memory here. That memory is used across on this VM, VM2, VM3. Same for your network card. Your network card is virtualized. Used on that VM1, VM2, VM3. And same thing for your storage is virtualized. We use it on VM3, VM2, and VM1. Now the good part about this is this enables you to consolidate and run multiple workloads on virtual machines on a single computer. So with that being said, a virtual machine is a computer that's created by software like a physical computer that runs the operating system and its applications. And as you see right here within the virtual architecture, we have our operating systems along with our applications running across the entire vSphere architecture, right? That is included in all of this. So with that being said, we're sharing the CPU, the memory, the network, and the hard drive, and we're virtualizing it so VM 1, 2, and 3 can use it, versus over here at the physical architecture side, the only machine that can use the CPU, memory, the network, and the hard drive is this physical machine. Let's take a look at physical resource sharing. With virtualization, you can run multiple virtual machines on a single physical host. And what we mean by a single physical host is that each virtual machine basically shares the resources of that one physical computer across multiple environments. And the same thing like I pointed out a little bit ago in the previous slide, which was here. Same thing you see here. The physical resources are being utilized. So you see we've got the CPU is coming across, is sharing here, and is sharing here. So we'll name this one VM1, VM2, VM3. Same thing with your memory. It's being shared here for VM1, VM2, and VM3. Then you look at your network card. Your network card is basically being used on VM1, VM2, and VM3. Then you got your hard drive being used across for VM1s, VM2, and VM3. Now how does that work? The virtual machines share the access and are scheduled to run by the hypervisor. And what this does, it assigns them, like say we want to look at memory. It assigns each virtual machine a portion of that memory to be utilized and shared across whatever amount of memory that you have here. So if you have 1 terabyte of memory, it's going to share that memory across all 3 VMs here, 1, 2, and 3. Same thing, your CPUs right here. They're going to share their resource across VM1, VM2, and VM3. Same thing for your NIC, same thing for your hard drive. Now, virtual machines run on different types of CPUs. They're like applications. They use bandwidth, they use your network. But the biggest thing to know here is virtual machines are managed elaborately through mechanisms to control how much access is available of these resources. So with the default allocation setup, all the virtual machines associated with the same ESXi host will receive an equal share of the available resources down here unless otherwise stated. So what is CPU virtualization? Very important to know that CPU virtualization is not emulation. In a physical environment, the operating system assumes the ownership of all the physical CPUs in the system. CPU virtualization, it basically focuses on performance and runs directly, basically, it takes all the available CPUs and runs. So as you see right here, on the physical architecture box, we have your application, your operating system, and your CPU. The only machine that can use all the allocated CPUs are dedicated to that one machine of the physical architecture. Virtual architecture. You notice the CPUs here? You have these 4. They're allocated across VM1, VM2, and VM3. And once again, CPU virtualization is not emulation. A software emulator enables programs to run on a computer system other than the one for which they're originally written. Emulation provides portability, but has a negative impact on performance. So how does CPU virtualization work within a virtual architecture? CPU virtualization is not an emulation because the supported guest OS is designed for 64-bit processors. And as you see right here, you have your 64-bit architecture built in already. And what that does, with that being its design to that, the hypervisor allows the operating system to run natively on the host physical 64-bit processors, which you see right here, these 4 CPUs. So if you take that into account, you have several virtual machines running on an ESXi host, then those virtual machines may compete for the CPU resources. When CPU contention occurs, the ESXi host basically takes those physical processors across all virtual machines and slices them so that each virtual machine runs as if they had a specific number of virtual processors. So as you see right here, I have VM1, VM2, and VM3. It just took those CPUs and sliced them to use with VM. As you see, VM1s where it's using 1 CPU, VM2s 2, VM3 is using 4, and it allocates them based on use. So what is your physical and virtualized host memory? Basically the same thing. In a physical computer or a physical environment, the OS assumes the ownership or consumes all of the physical memory inside the system. So if I take my computer that I have here at my office and I put 16 gig of RAM in it, then only my computer is going to utilize that 16 gig of RAM. In a virtual architecture, which is here, if I have 16 gig of RAM, in this case, let's just say we have 16 gig of RAM. We got VM1, VM2, and VM3. VM1 is only allocated 1 gig. VM2 is allocated 2. VM3 is allocated 8. So what's that do? That's telling you it's got 11 gigabyte, or 11 gig of memory left. Or we're using 11 gig, but we have 5 gig left over. So with that being said, if we had the CPU, the memory, the disk storage, the network out there available, we could add another VM. We could say, okay, let's add VM4 right here, and let's give it 3 gig. So then that would take us from utilizing 11 to 14 gig, or 11 to 14, so we got actually 2 gig left over for another machine. So basically, that is your the difference between physical and virtualized host memory. Now, virtual memory, as we know, is a decade-old technique, and it's been used a lot. I mean, it's been used for the past several years. Virtual memory also, or basically virtual memory, with that being said, it's been used over several years in most general operating systems. Virtual machine or virtual memory enables operating systems to present more memory to allocations than they physically have access to. And basically all your modern processors have hardware to support it. Virtual memory within a virtual architecture, it basically creates a uniform virtual address space for the applications and enables the operating system and the hardware to translate how to handle the virtual address space and the physical address space. Okay? With that being said, that technique has adapted the execution environment to support large address spaces, process protection, file mapping, and swapping into modern computer systems. In a virtualized environment, not your virtualized memory, in a virtualized environment, the virtualization layer creates a contiguous addressable memory space for the virtual machine once it's started. The memory is then allocated to be configured when the virtual machine is created that has the same properties as the virtual address space. That configuration then enables the hypervisor to say, okay, let's run on multiple virtual machines simultaneously while protecting the memory of the virtual machine that is being accessed by other VMs. So as you see right here, we're running multiple shares of memory across this architecture. Physical and virtual networking. The virtual Ethernet adapters, virtual switches, are basically key to your networking components. And with that being said, it's important to know that in a physical environment, the operating system assumes all the ownership of the physical memory in the system. Same thing with the CPU, same thing with the memory, same thing with the network card. The only machine that's going to use this one right here is this physical machine here. Okay? I know we keep harping on it and we keep saying that each memory, but it's important to know that on a physical machine, the only machine that's going to use that network card is that physical machine. What about the physical architecture? So the physical architecture, basically, or your virtual Ethernet adapters, can be configured multiple places. And when you have your multiple Ethernet adapters, which you see here, you have what we call a virtual switch, which is here. That virtual switch's main component comes down to the main network card and that physical architecture, 64-bit architecture that you see here at the bottom. Virtual switches enable the virtual machines on the same ESXi host to communicate. So we have VM1, VM2, and VM3. Since we have this network card here, and we have it connected to a virtual switch, and we have 3 NICs configured, NIC 1, NIC 2, and NIC 3, all on the same virtual switch. So what that does, that allowed, okay, man, I want VM3 to connect to VM1. Done, no problem. I want VM1 to connect to VM2. No problem. Virtual switches also support VLANs. So if you've got a voice VLAN, or you have a different VLAN set up for a different section of your company, done. You can set it up. It supports it. It supports multiple VLANs. They are compatible with standard VLAN implementations from other networking equipment. And also with the VMware Virtual Networking, you can link local virtual machines together and link local virtual machines to an external network through this virtual switch also. Now, a virtual switch, what is it? It's like a physical Ethernet switch. It forwards the frames to the data link layer. And with that being said, the ESXi host then contains multiple virtual switches. The virtual switch then connects to the external network through an outbound Ethernet adapter called VM NICs. So guess what? These are your VM NICs. Making sense now, right? So since now we have our VM NICs, it binds those VM NICs, or takes those, is capable of binding multiple VM NICs together, or NIC teaming on a traditional server, and offers a greater a greater bandwidth, greater use, a better use of it to use the virtual switch. So, like your physical switch, each virtual switch is isolated and has its own forwarding table. So every destination to the switch looks up and can match only ports on the same virtual switch where the frame basically originated from. By doing the virtual architecture, the virtual switch, it improves security, making it difficult for hackers to break your virtual switch isolation. So we can take it, we can isolate this virtual switch. Sure, it makes it harder to get it, right? So once that virtual switch is there, it supports VLAN segmentation on the port level, so that each port then can be configured as an access or trunk port that provides access to single or multiple VLANs. So we can have VM2 on its own single VLAN, then we can have VM1 and VM3 on its own VLAN. Now, you may ask, STP, Spanning Tree Protocol. Virtual switches do not require it, okay? Because you have a single tier networking topology being utilized here. Multiple virtual switches cannot be interconnected, and the network traffic cannot flow directly from one virtual switch to another virtual switch on the same host either. Virtual switches basically provide all the ports that you need in one switch, which is that virtual switch there, and do not need to be cascaded because virtual switches do not share physical Ethernet adapters. So with that being said, there's no leaks that occur between virtual switches. So we could actually add another virtual switch here, right here, and have them all integrated. Then you would have no links because we're running it down here off of the physical infrastructure. VMFS, Physical File Systems. What is VMFS? VMFS enables a distributed storage architecture allowing multiple ESXi hosts to read and write to the shared storage at the same time, concurrently. Okay? So what is it? It was designed and constructed, or basically built and optimized for virtualized environments. VMFS, basically a storage solution that is high performance cluster of a file system designed for virtual machines. VMFS uses distributed journaling of its file system metadata, and that changes to enable fast and resilient recovery in case of a hardware failure. Now, with that being said, VMFS, it increases resource utilization by providing multiple virtual machines with shared access to a consolidated pool of clustered storage. So let's see what we have right here in this slide. We have our physical architecture once again, our virtual architecture. Our physical architecture, NTFS, UFS, ext4, all that good storage, how we could set it up, blah, blah, blah. So we have our storage pool, right? Or a hard drive, HDD or your SDD. Remember, this physical architecture here, we'll just name PM1, Physical Machine 1. Physical Machine 1 is the only one that can use that storage. Okay? On the virtual architecture, we have shared storage. vSphere, we got virtual volumes, VMFS, NFS, vSAN. And what that does, it provides an interface to storage resources so that several storage protocols such as Fiber Channel over Ethernet, iSCSI can be used to access data stores on which the virtual machines can reside. So here you see we have one virtual environment here. So we'll name this V1, virtual environment 1. We'll name it VE2. Actually, I should have named this VE1. Virtual environment 1, virtual environment 2. Okay? That's its own set. We have VM1 in virtual environment 1. We have VM2. VM1, VM2. The good part about VMFS, virtual machine file storage, is with us having access to the storage resources being shared basically over fiber channel over Ethernet or iSCSI, is the dynamic growth through aggregation of the storage resources and the dynamic expansion of the VMF data store enables you to increase the shared storage pool with no downtime. So if we allocated, say we have a 10 terabyte drive down here. I want to allocate 3 terabyte here on VE1. I want to allocate 4 terabyte here on VE2. The good part about it is being I have 3 terabyte left over, you know what? I really want to give that 500 more gig of storage space. Got some more stuff we're going to be adding. Maybe going to be adding a new VM to Virtual Environment 1 here. Let's take this down to 2 terabyte, add 1 terabyte here. Now we have 4 terabyte. And as I stated before, we have no downtime because we were able to increase the storage size because it's all shared within one environment. Okay? Now with that being said, the distributed locking methods, or basically with distributed locking methods like that, VMS forges the link between the virtual machine and the underlying storage, which is here, the virtual machines to the underlying storage, right here. And it takes that and has a unique capability that enables the virtual machine to join a cluster with no issues and no management overhead and needed to manage the shared storage across the virtual architecture. Encapsulation. Virtual machine files are stored in directories on the VMFS, NFS data store, VMware vSAN, and virtual volumes across the data store. Okay? So we have virtual machine files. Now, as you notice, we have our shared storage pool, once again, here. We have VM1, which has its own storage file, VM2, and VM3. Virtual machine file storage, VMFS, provides encapsulation of the entire virtual machine so that it become a part of the business continuity or disaster recovery solution. So we have VM1 or VM3, VM2, and VM1 utilizing all of this storage simultaneous with its own storage files. So how does the vSphere client come into play right here? Version 6.5, we now have vSphere Web Client. Alright, that we started using. The vSphere Web Client is a browser-based, basically a platform-independent user face. It's based on Adobe Flex. All operations necessary for working with vSphere, your ESXi host, your vCenter server, are possible within this vSphere Web Client. What is the vSphere Client? The vSphere Client is a basically a Windows OS installed application on your machine, local to your machine, that has access, basically as legacy user interface here, that has access to your vCenter server, your ESXi host, right? So we talked about the web client. Now, let's talk about Actually, let me highlight something on the web client. The web client is HTML5 based, and there are two new base clients with benefits. Both of them are clean. To me, they work a lot better. They're more user friendly. They look better. It's no browser plug-in, and they're integrated into vSphere and your ESXi host now. So your vSphere web client has the following components. As I said earlier, based on Adobe Flex client application running in a browser. The Java server is embedded into vCenter Server Appliance 6.5. I would remember that. A thin client, which requires only a browser with Adobe Flash plugin, is installed. And to access that, here is how you could access your vSphere client. As you see in this photo screenshot here, we're going to our VSSA01 vClass local vSphere client. Well, that's how we access it. It's through that integration plugin. And also know that it will automatically redirect you to port 9443. The vSphere web client, the new GUI or web client, I apologize for that, includes new features such as custom attributes, object tables, live refresh, and presents with other performance and usability improvements. The client integration plugin is no longer required here. The client integration plugin, which can be a pain. There are some times I've experienced it, and I'm still experiencing it now, where I can't get it to work. I have to do a lot of different go in and change files and do this and change things. Well, it's fixed now in 6.5. So with that being said, being it's no longer required, it was redesigned to remove that dependency of the data store file upload download. It takes away the problems you have with OVF exports, deploying them, the content libraries, importing, exporting, and the only remaining function that has dependencies within this now is when you need an exception to install the enhanced authentication plugin. The vSphere client, HTML5 based, not dependent on Adobe Flex. The vSphere client uses the same Java server as the web client. Shows you once again here how you can access it through your PC. And with that being said, this automatically internally redirects you to port 9443 on your vCenter server. This vSphere client, basically in 6.5, enables you to manage vCenter Server Appliance through the web browser, but has no requirements, once again, for Adobe Flex to be enabled in the browser. Then we have the host client. The host client provides direct management access to individual ESXi hosts. It requires no dedicated installation time configuration, and the VMware host client is served from the ESXi 6.5. So let's go back a couple slides. Let's go back to your vSphere clients, all of them working together. As you notice here, we have our desktop or our PC. We have three methods to get to it. Over top of this class, go research the vSphere client. Go research the vSphere web client. Go research the vSphere host client. In this class, tell us some differences you found in a discussion post. Let us know what you prefer, what you don't prefer, why you like one of these three, what don't you like about one of these three. There's a lot of dialogue that can be started and a lot of help that we could do discussing things by showing tips in the discussion forums for other people to pick up and not pick up using these that may help us throughout the class. And with that being said, use your discussion posts once again, go through, look at this, study them, and let us know what you think within a discussion forum. Now you should be able to meet the following objectives. Explain how a virtual machine is a set of specific and configurable files. Describe how a virtual machine is a guest and a consumer of host resources, meaning that you got your physical resources and you have your virtual resources. Explain how vSphere interacts with CPUs, memory, networks, and storage. You should be able to navigate or know how now to get where you can navigate the vSphere web clients and use the vSphere web client to access and manage your vCenter server and your ESXi host.